factoring. It's just a little hodgepodge review of some good algebra factoring. Let's say, for instance, first they give you something with two terms. They could give you something nice, like let's say 7x plus 14. The only thing you can do with that is look for greatest common factor. What do they have in common? Of course, it's 7. So if you factor out a 7, x plus 2. In other words, if you divide each of those by whatever you put on the outside, x plus 2. Like if I had 3x cubed minus 9x squared. Well, they both have, the biggest thing they have in common is a 3. 2x's and 3x's, so 2x's, because remember you always go for the smallest number. And then to see what's left, if you divide this by 3x squared, you got 1x, and bring down the sign, 3. Now you can also factor monomials with 3 terms. Typically that would look something like this if, let's say, I don't know, something like this. Well, 10, 30, and 15, the biggest number that they have in common as a factor, 5. Then you've got 2x's, 1x, 1x, so smallest number of them, 1x, 1y, 2y's, 3y's, so smallest number, 1y. So you're going to literally divide this into each of them to get your answer. So 5 goes into 10, 2, y's cancel, 1x, plus 5 goes into 36, x's cancel, a y, minus 5 goes into 15, 3, x's cancel, 2 y's. So if you have something weird like that, and it's even a trinomial, it's probably something like that, and that's all you can do. But let's say they give you something nice like this. It's called difference of squares. It's always 2 terms, and they always go back to things that are perfect squares. Because the good news about it, they're called conjugates. They are the exact same except opposite signs in the middle. Because when you do the full method, the outers and inners will always cancel and just give you first minus the last. So square root of x squared, x and x, plus and a minus, square root of 49, 7 and 7. X squared minus 81, x and x, plus and minus, 9 and 9. If they tried to be tricky and throw a y squared in there, you just put a y in there. No biggie. Now, let's say they gave you x squared plus 25. Well, that is not a difference of squares. So for now, we're going to say we can't do it. Technically, if we consider imaginaries, we can. It's plus or minus 5i. But for now, since this is for my algebra class and we're sticking to real numbers, you can't do it. It's impossible. Let's say you had something like this, though. 6x squared minus 24. Well, you might be saying, well, the x squared's fine and dandy, but 6 and 24 does not have a perfect square. No, they don't. But they have a 6 in common. So if you factor out the 6, you would get x squared minus 4, which that, of course, does factor. X plus or minus 2. Let's say they even made it where it wasn't necessarily something you could factor out, but let's say different coefficients. 9x squared minus, we'll say 64. Y squared. Square root of 9x squared, 3x. 1 plus 1 minus, doesn't matter the order. 8y and 8y. So if it's two terms and it's not something you can just take something out, if it has any, looks like perfect squares, it's probably a difference of squares. Now, trinomials. Trinomials are one where, remember, you've got your signs, plus plus, two pluses, minus plus, two minuses, and you're always trying to add to get the middle number. Plus minus, minus minus is one each. You're always trying to subtract to get the middle number. So like this one, minus minus. So that means 1 plus, 1 minus. What can I multiply to get 30, but subtract to give me my understood 1? If you guess 6 and 5, you guess correctly. So now the thing is, in order to get a negative x, which one is going to have to be negative, the 6 or the 5? Negative 6, positive 5, negative 1. Let's say x squared plus 12x plus 20. Same thing. X and x, two pluses, so two pluses. Multiply to give you 20, add to give you 12. 10 and 2, 2 and 10. Now, let's say they had given you something like 5x squared minus 25x plus 30. Notice how I know you're already grumbling, going, oh, it's those coefficient ones. Actually not. 5 goes into all of them. So x squared minus 5x plus 6. So minus and minus. What multiplies to give you 6 adds to give you 5? 2 and 3. So see, that one was one you could just take something out of. But let's say it wasn't. Let's say it was something like 5x squared minus 42x minus 27, where it's just, ugh. Remember, 5x and x, always 1 plus, 1 minus, because 2 minuses, we just don't know where. 27, 9, 3, 27 and 1, but I would probably stick with a 9 and 3. Okay, so we're doing something, one of those by 5, the others just by 1. And trying to get 42, which is really close to 45, and 3, 42x. And for the 42 to be negative, 45 had to be negative. Ooh. So there you go. Now, you also could have a nice one. I didn't do one of these. If I gave you like something like this one. It's the same, plus and minus, plus and minus. Multiply to give you 24, subtract to give you 2, 6 and 4. But since there's a y in the middle and 2 y's on the end, you just put it in the back. So that's 3 terms. Lastly, let's say you have 4 terms. Not very common, but they're out there. Remember, all you have to do is look at the first 2 and the last 2, and typically that'll get you there. So the first 2, what do they have in common? An x. So you're left with a plus b. The second half, a 5 in common, so you're left with an a plus b. So they both have an a plus b in common, and then an x plus 5 is left. Just like if it was 2x squared minus 6x and xy minus 3y, same thing. Notice how you could look at the first two, and they have a 2x in common. So that would leave an x minus 3. These have a y in common, so that would leave x minus 3. So x minus 3, and then a 2x plus y. Now, if you're interested and need sum and difference of cubes, I do have a separate video for it. We just didn't get to it in Algebra 1, and originally that's what I'm making this video for, that class. There's also some other more unique factoring. They're not very popular, but as far as they're not bad to know, but the general, a good probably 80% portion, if not 85 of what you typically see, is what we did today. Hope it was of help to you, and you have a great day.